So let's start with number 1. Again, anytime we are solving a system of equations, we are going to solve for y. So in this case, to solve for y, you'd subtract x and then divide by 3. What makes number 1 kind of gross is that the y-intercept is a fraction. So rather than starting the graph at the y-intercept, we're going to start our graph at the x-intercept. So the x-intercept is the point where y is equal to 0. It's where it crosses the y-axis. So the x-intercept is x plus 3 times 0 equals 2. Well, anything times 0 is 0. So the x-intercept is 2. So what that means is that this is the point on the graph to 0. So instead of starting at 2/3 over here, we're going to start at 2, 0 over here. My slope is still negative 1/3. So after I get this point, I can just apply my negative 1/3 slope to that point. So up 1 and over 3, up 1 and over 3. And connect my points. And then similarly, we're going to solve or graph this equation. So again, you have to solve for y. And you get y equals negative x minus 2. So you start at negative 2 for your y-intercept because that is a nice whole number. My slope is negative 1, so I'm going to go down 1 and right 1. That doesn't cause my line to intersect, so I'm also going to go up 1 and right 1. Which does allow me to see a point of intersection. So what that means is that these two graphs intersect at negative 1, 2, 3, 4. And when y is positive 2. So my solution is negative 4, positive 2. My solution is the point of intersection. And again, if they intersect, then my lines are described as intersecting, independent, because they have one solution. Let's look at example 2. Solve for y. So what's my y-intercept? It's at positive 5. And then you say, what is your slope? Negative 2. So you're going down 2 and right 1. Connecting our points. Bless you. So that gives my first graph. Then we're going to get the second graph by adding over x to the other side. So I have y equals positive x plus 2. Plot your y-intercept of positive 2. Apply your positive slope. And I see that the graphs once again intersect when x is 1 and y is 3. So my solution is the 0.13. And once again, we would classify as independent, intersecting, and they have one singular solution because the graphs can only intersect once. Take out your graphic calculators. We're going to turn them on.
How do you know if it's independent or not?
That's our definitions for solutions. So independent are intersecting. Coinciding are dependent because it depends on the other line. And parallel are inconsistent because they have no solutions and never intersect. All right, so on our graphing calculators, we are going to enter in some data. So go ahead and hit Stat. Go to Edit. And hit Enter. L1 is going to represent our weeks because that's our X value. L2 is going to change. It's going to be Ed and Joe, depending on which one we're looking at when. So right now in L1, I have my weeks 1, 2, 3, 4. But in L2, I don't have Ed's data, so I need to type Ed's data into L2. So I'm going to replace my L2 with 50, 55, 63, and 67. Then I'm going to hit Stat. Go over to Calculate, go down to option 4, and hit Enter, so that it gives me my A value, which is my slope, and my B value, which is my y-intercept. So that gives me the equation of Ed's line. So I'm going to go over to Ed on my paper and write down his equation of y equals 5.9x plus 44, where the calculator gave me an A value of 5.9 and a B value of 44 for y equals ax plus b. We're going to go do it again, but this time for Joe. So hit Stat, go back to Edit. In L2, you're going to enter Joe's data. So 40, 47, 56, 62. Hit Stat, go to Calculate, go to option 4, and we get y equals ax plus b. So my A value is 7.5, and my B value is 32.5. So I write down Joe's equation as y equals 7.5 x plus 32.5. So then it says use the graphs of the model to predict the week in which they could be the same. So since we don't algebraically have a way to do this and I didn't make you graph it, we're going to use the graphing calculators to graph it. So you're going to go to y equals right here. You're going to clear out anything in y1 and y2. In y1, we're going to type Ed's equation. So in y1, I want you to type that 5.9x plus 44. In y2, you're going to type the 7.5x plus 32.5. Is everybody good? Figures. So once you have your equations typed in, we now need to make the graph area fit. So if you just take graph right now, what you'd see, at least for mine, is like two lines kind of lightly on top of each other stuck in a corner. So that's not very helpful. So what we're going to do is hit the word window. So that's what I said, our graphs are, we need to fix our graphs to be what they need them to be. So hit the word window. Our X values, according to our data, are the weeks. So right now my X values are 1 to 4. So what we're going to do is change my X values. The min could stay 0. But right now my max was at 100. I'm going to make my max 10. And my scale 1. So it goes by 1 week at a time. My y min, well, that needs to be my y-intercept. So which intercept is smaller? Yeah, so I'm going to make my x min 30. Because I don't need, there's not ever going to be less than 32.5 because it's positive slopes and that's my y-intercept. So now I'm going to hit graph. So this line represents Ed. This line represents Joe. Does it appear that the two lines cross? The answer is yes. Okay. So what you're going to do now is, does everybody have those two lines? Yeah, it has to be bigger than 30. Yeah, your y max, sorry, I picked 100. Sorry. All right, here's the part that you're going to be like, oh my goodness, this is so awesome. We're going to use the intersect feature in the calculator, so you're going to hit second right here. And then the word trace right here next to graph. So you have to hit second and trace. And then this screen pops up. And then what do you notice option 5 is? What are we learning about? What does the intersect represent? Fantastic. So you're going to go down to option 5. Hit enter, or you can just press the 5 key on your calculator. We can move this close to where they intersect, but it really doesn't matter. You're going to hit enter once, enter twice, enter 3 times, and then what you're going to notice is it's going to give you the answer down here. So X represents weeks, Y represents shoes. So what it means is that during week 7, Ed and Joe will both sell 86 pairs of shoes. So down here, the question was, when will our graphs intersect and they sell the same number of pairs of shoes? That is going to be at week 7. They will both sell 86 pairs of shoes. I think, are we okay with getting everything in the calculator using linear regression, etc.? Everybody okay with doing what we just did? Okay, flip over. You're going to put an X on your notes for this part. I'm not going to make us type all these crazy decimals into the graph. We spent a ton of time doing linear regression this year. What I want to do is go to the next question with you. Because you guys always say, when can I use this in real life? So right now is a great time to talk about coupons and discounts and this and that. So stores run different events. Some stores offer multiple coupons at a time, and it is your responsibility to kind of figure out what coupon's going to save you the most money. So X represents the original cost. Y represents the cost you are going to pay. So there are all sorts of different coupon costs. So one of the costs is just $10 off. So if you have a coupon for $10 off and the cost of the item is $20, how much do you pay? Yeah. But if your cost of an item is $20 and you have a $10 off coupon. Yeah. $20 minus 10. 10. So that coupon equivalent would be what percent? 50. So if you had to pick a $10 off coupon on a $20 item or a 15% off coupon, what are you picking? The $10. If the item is $75, 75 minus 10 is, how do I figure out what 15% off of $75 is? Okay, so do 0.15 times 75, and what do you get? 11.25. Yeah, so I'm not paying 11.25 for the item, I'm paying how much? Okay, so now what coupon is better? Because I'm saving $11.25 versus $10. Okay? Instead of saying 15% of 75, how could I have done this in one calculation? Excellent, because I'm still paying 85% of the retail price. So instead of doing 0.15 times 75 and then subtracting that number from 75, I can do 0.85. So if something is 25% off, what am I paying for the price? So if it, well, this is 15%. If I said something is 25% off, what's my equation become? There you go. Good. All right. This is what tricked my ones that make me angry. If it's buy one, get one, half off. Okay, so let's say we buy a shirt, and the shirt is $10. What will be $10? So if you buy a $20 shirt, so if it's buy one, get one, half off, the first shirt I pay full price, right? Second shirt I get half price, so the second shirt costs me. How much do 2 shirts cost me? Buy one, get one, half price is the equivalent of what percent off of both? Since it's not really, because this is 100%, this is 50%. Yeah. So buy one, get one, half price is not really half price. It is just making you spend more money to get 2 items at 25% off. See, anger coupon. Let's see then, at what price should I use a $10 versus a 15%? So we already determined the 15% is better for $75 and a $10 coupon is better for $20. So we're going to use the graphing calculator to determine where they are the same. So clear your equations. You have cost of the item minus $10, cost of the item with a 15% off coupon. This is why your windows were 0 to 100, 0 to 100, because $100 is kind of an easy price point, but we actually already saw 75 was a nice price point. So X min 0, X max 100, X Y min 0, Y max 100. Your Y max always has to be greater than your Y min. Why am I not doing negatives? Well, I'm never going to pay negative for items, so we don't care about the negatives. Hit graph. Do the 2 lines intersect? Yep. So we're going to use that second trace intersect tool to see where they intersect. So hit second, go to trace, go to intersect, hit enter 3 times, and we see that they intersect at a $66.66 item, which makes both a final cost of $56.66. So this is the price point with where they're the same. This is the cost of the item. That was if you did it by hand because you didn't have a calculator. So we're not going to look at that. But essentially that is what your graphing calculator is doing. So what you're going to do for the remainder of class is work on your homework. You have about 10 minutes, so it's the front and back of that handout. Some of the kiddos in period 4 got confused. These directions are for 26 through 31. 32's graph is here, 33's graph is there, 34 is here. So you're graphing 3, classifying 6, and doing the 2 word problems. For the word problems, for part A, there's not really any work in this space here. All I did was rewrite my equation, but you are basically just graphing those 4 lines. So your graph is going to have all 4 of those lines. So you're just graphing those. I would highly suggest going by 2's on your graph. Go by 2's on the graph.